Hey guys, today I'm going to teach you all about rational exponents. By the end of this lesson, you'll be able to simplify expressions when exponents are positive or negative fractions, those rational numbers. So go ahead and got your binder, turn to the math section. Let's go ahead and take some notes. So far, we've looked at exponents that are integers, like x to the power of negative 3 or 5 squared. But exponents can also include rational numbers, like fractions or decimals. Even though we might have fractions as exponents, it doesn't mean that the laws of exponents changed. We can still use things like the product rule. The product rule states that if two of the same bases are being multiplied, you can add their exponents. In the first example, 9 and 9 are the same base, and they are being multiplied. So that means that I can add their exponents. 1/2 plus 1/2 is 1. And we should know that 9 to the first power is the same thing as just 9. Using this example, we should be able to figure out what the value of 9 to the power of 1/2 is. What number times itself gives you 9? The answer is 3, because 3 times 3 equals 9. And in this case, 9 to the power of 1/2 times 9 to the power of 1/2 gave us 9. That means that 9 to the power of 1/2 has to be 3. Here's why. Raising a number to the power of 1/2 is the same as taking its square root. This is the symbol for square root. This number that goes here is called the index. Right now it's invisible. If you could see it, it would be a little 2 for square root, because squared has a little exponent of 2. Square root has this index of 2. It means what number times itself gives you this number. Big number is called the radicand, and this symbol for square root is also called a radical. Using this as our example of proof, we should realize that the square root of 25 is the same thing as 25 to the power of 1/2. These are equivalent. I would say this is written in exponential form, this is written in radical form. Let's look at B and see if we can figure out what happens when you take something to the power of a third. Start by using the product rule. Let's figure out what goes in this box. Since these are all the same base and they're all being multiplied, I can add their exponents. All that adds up to be 1. 8 to the power of 1 is the same thing as 8. What does that mean about the value of 8 to the power of 1/3? 8 to the power of a third is 2, because 2 is the number that multiplies by itself 3 times to make 8. That's because raising a number to the power of 1/3 is the same as taking the cube root. Cube root is similar to a square root because it still has the radical, except this time the index is going to be 3. In this case, if the radicand was 27, this little 3 means that what number times itself 3 times gives you that 27, kind of like we just looked at here. So this would be in radical form. This is the same thing in exponential form. In either case, the cube root of 27 or 27 to the power of 1/3 is 3. 3 times 3 times 3 is 27. When you see a base with a fractional exponent, you should realize that the denominator, or the bottom number of the fraction, tells you something about the root. You keep the base the same, that's going to become your radicand, and then you're going to draw that radical symbol. The number for the index is going to be whatever the denominator is, in this case, y. The numerator tells you what to take your new radical expression to the power of, in this case, x. Look at an example with numbers. Let's look at D. It says 8 to the power of 2/3. Start by rewriting the base. Then draw your radical, and then you need to pick out the index. The index is either 2 or 3. What I would always remember is its power over root. P comes before R in the alphabet. That could help you remember this. I have to put a little 3 here in between that little radical symbol. That means I'm looking at a cube root to start with. Now we have to deal with the top number. So it's 2, and it's always power over root. 2 is the power I need to take this expression to. The reason we rewrite from exponential form to radical form is because when you first look at this problem, you might not think you can solve it without a calculator. However, when you see this problem here, you would take the cube root of 8, which we found out earlier is 2, and then square it. 2 times 2 is 4. Let's work through A together step by step. 100 is the base, so I'm going to start by writing 100. Now I'm going to write the radical, and the number that goes here is 2, because it's power over root, and the bottom number tells me what to take the root of. So that is a square root. So if you didn't write that 2, that's okay. Don't see that little 2, it's implied that it's there, it's invisible. Now we need to take this to the power of 1, because it's always going to be a fraction that tells you the power over the root. The power in this case is 1. So if you didn't write that 1, does it change the answer? No, it doesn't. Either way, you're taking the square root of 100, which is 10. Hopefully what you noticed with that example and the 2 that we started with is that if x is 1, if that numerator is 1 in the fraction, it just means to take the cube root or the square root or whatever that bottom number is. That just becomes your index. That means what number times itself that many times gives you that number. Keeping that in mind, I want you to try B and C all by yourself and press play when you're ready to check. All right, so you should have got 3 for the first question and 6 for the second. If you were doing B without a calculator, I would start by trying to figure out what number times itself 4 times makes this number. It's helpful to make a list. I would start with 1 and do that 4 times and see what you get. Then 2, do that 4 times, see what you get, and so on. In this case, 3 to the 4th power is 81. Keeping those rules in mind for bases that were whole numbers, we can actually apply those to bases that are variables using those same rules. If we have a fractional exponent, it's always power over root. Keep the base b, call your radical, 4 is your index, and then 1 becomes your exponent. This problem is simplified, and you don't have to write the 1. It's the same thing as what we did in b, except this time we just have the variable b instead of an 81. Go ahead and try number 2 by yourself. Use the product rule to simplify this expression. Press play when you're ready to check. Since y and y are the same base and they're being multiplied, I can add the exponents. 1/2 plus 1/2 is 1, so I'm just going to write 1y. 6 just gets brought down because it's still its own base with its own exponent of 1. So 6y is the simplified version of this. For number 3, we have an exponent being taken to the power of another exponent. For that, we're going to need to use the power rule. The law of powers of exponents says that when you have a power to a power, you can multiply the exponents to simplify. In number 3, there are 2 bases, 81 and x. Each of those has their own exponent. The exponent on 81 is 1 because it's invisible. You can't see it, but it's there. There's 181. And what you want to do is take that 1/2 and multiply it to each of those exponents. And that means we now have 81 to the power of 1/2 and x to the power of 3. Are we done simplifying? No, and hopefully you realized that taking the square root of 81 is the same as taking it to the power of 1/2, which makes 9, and then just keep that base x with the exponent of 3. This is fully simplified. Go ahead and look at number 4 and apply the power rule. Press play when you're ready to check. -9 times 1/3 is -3. X to the power of -3 is correct. However, it's not fully simplified. Don't forget, we cannot have negative exponents in our answer. And when you see a negative exponent, you should think division. You should think fraction. Now our number does not have a fraction in it, so it's in the numerator. It's over an invisible 1. And right now it has a negative exponent. So if it's not happy in the numerator, it has to move to the denominator. And once it's down here, exponent is now positive. There has to be something on top, so put the 1. This is simplified. Number 5 has several different steps, but I would go ahead and try it as much as you can by yourself, and then I'll work through it step by step. Go ahead and try it now. For step 1, I'm going to go ahead and use the power rule. Since we have a power to a power, I'm going to multiply the exponents. X to the power of 12 times 4 to the power of 1/2 times x to the power of 5. So I'll use the product rule. Since x is the same as x, they have the same base, and they're being multiplied. So I can add the exponents. Gives me x to the power of 17, and then I'll bring down that 4 to the power of 1/2. Finally, I want to use my rational exponent property. When we have a power that is a fraction, it's always power over root. So I'm going to rewrite 4 with a radical. I'm going to make sure I put this little 2 here, but you don't have to because this means the same thing as square root. And to the power of 1. Again, you don't have to because this is the same thing. Then just bring down that x to the power of 17. And last step, simplify. The square root of 4 is 2. So 2 times x to the power of 17 is the most simplified answer. All right, for the next 6 problems, I'm going to be your partner, and we're going to apply properties of exponents and take turns rolling a die. As I go through and I'll roll the die, I'll do a problem, and then you do a problem, and we're going to go back and forth. First one I'm going to do 6. Number 6 has this all to the power of 0. Anything to the power of 0 is 1. Your turn. You have problem number 4. At this point, you should mute me and see if you can try to beat me to the problem. I'm going to do it right now. If you get it wrong, watch this part. So the first thing I'm going to do is the power rule. If it's a power to a power, I'm going to multiply the exponents. So I have h to the power of -9 times h to the power of 10. Now I'm going to use the product rule. Same base being multiplied. Add the exponents. I get h to the power of 1 or just h. Either way is right. All right, I rolled a 1, so you can watch me do this, or you can do it along with me and try to follow my moves. So the first thing I'm going to do is apply the power rule. Power to a power means I multiply the exponents. Half of 4 is 2. On the bottom, I have a negative exponent. I can't have negative exponents in my answer. X to the power of -3 has to move to the numerator. X squared stays there, but now it's got x to the power of 3. So the same base being multiplied, I can add the exponents. X to the power of 5 is my final answer. You got a 2, so try this problem all by yourself and then press play when you're ready to check. First thing you should have done is brought down the y to the power of -3, and then you should have applied the power rule up here. 1/3 of 1 is 1/3. 1/3 of 12 is 4. 1/3 of 3 is 1. Next, use the product rule, and then finally rewrite this expression in radical form. Remember, it's power over root. So this is a cube root of 27 to the first power. I don't have to write that exponent of 1. It's invisible. Keep that y, keep the z. Then you can actually take the cube root of 27. It is 3. So your final answer is 3yz. All right, it's my turn. I rolled a 3, so I'm going to work through this. If you want to try it by yourself, now is the time. All right, so I did the power rule, and then I got b to the power of -8 over b to the power of -16. Then I could use the quotient rule. Since these bases are being divided and they are the same, I can subtract the exponents. -8 minus -16 is actually +8. So b to the power of 8 is fully simplified. If you moved each one of those negative exponents and switched them around, you would have ended up subtracting them anyway, and 16 minus 8 is +8. So either way, we would have ended up with b to the power of 8. All right, you're unlucky. You got stuck with the hardest problem on here. Go ahead and try number 5 all by yourself, and then press play when you're ready to check. The easiest thing would be to take anything to the 0 power is 1, so just ignore it. And then we're going to go ahead and start by doing the easiest thing next, 24 divided by 3, which is 8. Now we'll go ahead and keep that. Next, let's look at the a's. A to the power of 6 is on the bottom, and the exponent's positive, so it's good there. However, this one is not. So move that to the bottom, and it's to the power of 2. Since they're being multiplied and they have the same base, add the exponents. That means and there's more b's on top, so it's going to stay in the numerator. Your final most simplified answer is a times b to the 4th power over a to the power of 8. For number 7, I'm going to get you started, then I'm going to have you try it. You have the shape of a square where every side is the same. You have the area of the square. You know that the same length times the same width multiplied by itself to get this. If you're trying to undo that, the inverse operation is to take the square root, or, right here, take the area to the power of 1/2. Go ahead and do that for this, and then press play when you're ready to check. You should have realized that this is like taking it to the power of 1/2. So take that 1/2 and use the power rule. Multiply it out to each exponent, and you end up with this. The square root of 64 is 8, so this is even simpler. Number 8, and decide who completed the task correctly. In case it was Cedric, parentheses make the difference. If it was just x to the power of 1/2, that's its own term with its own exponent. 50 has its own exponent as well. It's 1, and that wouldn't be equivalent to this. Last thing, go ahead and try 9 or 10 or both by yourself, and then press play when you're ready to check. For number 9, when you have an exponent that is negative, it doesn't make the base negative. It actually just makes it a fraction. And fractions are greater than 0. They're not negative numbers, but they are less than 1. So look at number 10. Loretta multiplied 16 by 1/2 instead of taking the square root. The expression should simplify to 4 times m times n to the 10th power. And that's it. Thank you for watching. If you have any questions, please let me know. Bye!